Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on analysis of continuous time signals, that is Fourier transform. Fourier transform can be applied for both periodic and aperiodic signals. It can be represented in frequency domain. It provides the effective transformation link between the frequency domain and time domain representation of the signal. The spacing between the spectral components become infinitesimal and hence the frequency spectrum appears to be continuous. Periodic signal has a fixed time period T0. The continuous time Fourier transform is represented by x of omega is equal to integral over minus infinite to plus infinite x of t into e power minus j omega t into dt. Inverse Fourier transform x of t is equal to 1 by 2 pi integral over minus infinite to plus infinite x of omega into e power j omega t into d omega. X of t continuous time Fourier transform pair with x of omega. Next one, convergence of Fourier series, nothing but Dirichlet's condition. It has a single value property, but have only one value. Finite discontinuous, x of t should have at most finite number of discontinuous in the interval t0. Finite peaks, x of t must have a finite number of maxima and minima in the interval t0. Absolute integrability, the signal x of t should be absolutely integrable, that is nothing but integration of x of t into dt should be less than infinite. This is the representation of the signals. It can convert from time domain into frequency domain with respect to time and amplitude. Time domain it can be represented by t, that can be represented in terms of frequency domain, it's termed as 1 kilohertz. Similarly, the signal can be divided by 2, it can be represented by t by 2. Similarly, the amplitude, the frequency domain representation is 2 kilohertz with respect to amplitude and frequency. Next one, Fourier transform of signum function can be represented as 1 for t greater than 0 minus 1 for t less than 0. Sinc function can be represented by sinc of x is equal to sine pi x divided by pi x. The graphical representation can be shown. Next one, in the Fourier transform for the analysis function, the time domain can be converted into frequency domain. That is nothing but f of s is equal to, while we taking the Fourier transform of time domain function, we can get the frequency domain function. This is for analysis and synthesis function. See, s of t and s of t forms the Fourier transform pair. That is nothing but time domain and frequency domain. Next one, representation of Fourier transform in terms of periodic impulse train with respect to minus 2t to plus 2t with respect to x of t. While we are applying the Fourier transform of the periodic impulse train, Fourier transform can be represented in terms of x of j omega. The amplitude bit gets 2 pi by t. Therefore, the limits from minus 4 pi by t to plus 4 by t with respect to omega. Next one, now we can see the Fourier transform of decaying exponential function. X of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. Instead of x of t, you can put it as e power minus at into u of t. U of t limits varies from 0 to infinite. Now we can take e terms as common, ts minus t as common, a plus j 2 pi f. Now we can going to differentiate and integrate with respect to 0 to infinite. We can get x of f is equal to 1 divided by a plus j 2 pi f. Next one, similarly for rising exponential function, x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. E power at into e of minus t means limits varies from minus infinite to 0. Now we can take it as t as common. We can get, now we can going to differentiate and integrate. We can get e power 0 will get 1 divided by a minus j 2 pi f. Next one, find the Fourier transform of unit step function x of t is equal to u of t minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. U of t means limits varies from 0 to infinite. Therefore, now we can going to differentiate and integrate. We can get it as x of f is equal to 1 by j 2 pi f. Similarly, for Fourier transform of unit impulse function, see unit impulse function, whatever the transform of unit impulse function, we can get x of f is equal to 1 based on the condition del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Next one, what are the applications of Fourier transform? It is used in telecommunications, that is GSM and cellular phones, electronics, most DSP based applications, entertainment, music, audio, multimedia, and then medical for CAT scans and the MRI interpretation from sleep disorder and heart malfunction diagnosis, industry and research, X-ray spectrometry and radar design, image processing. Now we can going to see the assessment. Fourier transform is used to analyze both periodic and aperiodic signals. It can transformation from the time domain into frequency domain. Define convergence of Fourier transform, single value property, finite discontinuous, finite peaks, and then absolutely integrable. Fourier transform of unit step function is given by x of s equal to 1 divided by j 2 pi f. The decaying exponential function of Fourier transform is given by x of f is equal to 1 divided by a plus j 2 pi f. Fourier transform of unit impulse function is nothing but x of f is equal to 1. List the applications of Fourier transform. It is used in communication, it is used in entertainment, and then electronics, image processing, medical imaging, etc. Thank you.